How many planets exist in the air, space? Have you ever looked up at the night sky and wondered how many worlds are hidden beyond the tiny pinpoints of light? Every star that twinkles overhead is like a lighthouse in the vast ocean of the universe, and around those stars, there may be countless planets circling, each carrying its own secrets, its own mysteries, and perhaps even its own form of life. For centuries, humans have been obsessed with this question: how many planets exist? Our ancestors gazed at the heavens, gave names to the bright wanderers, and built stories about gods, heroes, and destinies tied to those planets. Today, with powerful telescopes, space missions, and the growing field of astronomy, we can finally move beyond myths and begin to uncover the truth. But the answer is not simple. It is not just about counting the 8 planets we are taught in school: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. It is about recognizing that our universe is unimaginably huge, containing billions of galaxies, and in each galaxy, billions of stars. If each star has its own planetary system, then the number of planets in existence may not just be in the millions, but in the trillions. And when we imagine all those planets, we start to realize that our Earth is just one tiny, in an endless cosmic sea. In this script, we will dive deep into the idea of planets. We will explore what a planet is, how many we know about, how many might still be waiting to be discovered, and how humanity's understanding of planets has changed over time. From ancient astronomers to modern space telescopes like Kepler and James Webb, from the planets in our solar system to the exoplanets circling distant stars, this journey will open our eyes to the breathtaking scale of the universe. And perhaps the most exciting question of all is this: if there are so many planets, how many of them could be like Earth? How many could carry the breath of life? To begin answering the question of how many planets exist, we must first ask a simple but important question: what is a planet? The word planet itself comes from the ancient Greek word planetes, which means wanderer. To the people of antiquity, planets were strange objects in the sky that moved differently from the background stars. While stars seemed to stay fixed in their constellations, planets wandered across the heavens. The 5 brightest, Mercury, Venus, Mars, Jupiter, and Saturn, were known for thousands of years. People had no idea what they truly were, but they recognized their unusual behavior and gave them a special status in their myths and calendars. As science advanced, our definition of planets began to change. In the 16th century, Nicholas Copernicus proposed a revolutionary idea. Rather than the Earth being the center of the universe, it was actually one of several planets orbiting the Sun. This was a turning point in human history, shattering old beliefs and giving birth to modern astronomy. Over time, telescopes revealed more planets in our solar system: Uranus in 1781, Neptune in 1846, and Pluto in 1930. For a long while, Pluto was considered the 9th planet, until in 2006 the International Astronomical Union, IU, redefined what counts as a planet. According to the IU, a planet must meet 3 conditions. It must orbit a star, it must be large enough to be shaped into a sphere by its own gravity, and it must have cleared its orbit of other debris. Pluto failed the 3rd rule, and so it was reclassified as a dwarf planet. This redefinition taught us that planets are not just any large body in space, they are special objects with precise criteria. But it also opened a bigger question. If our solar system has 8 recognized planets and several dwarf planets, how many might there be around other stars? This is where the story of planets expands beyond our small neighborhood. The modern search for planets has gone far beyond the visible sky. Scientists now use powerful telescopes and advanced techniques to look for worlds circling distant suns. These are called exoplanets, planets outside our solar system. In 1992, the first exoplanets were confirmed orbiting a pulsar, and since then, discoveries have multiplied at an astonishing rate. As of today, thousands of exoplanets have been confirmed, and the number grows each year. Some are gas giants larger than Jupiter, some are rocky like Earth, and some are in the habitable zone, the perfect distance from their star where liquid water might exist. Thus, the idea of what a planet is has stretched from the few wanderers seen by ancient eyes to a universe full of possibilities. When we ask how many planets exist, we are no longer speaking of just a handful, we are speaking of worlds beyond number. When we talk about planets, the most natural place to begin is our own solar system. It is our cosmic home, the region of space we know most intimately, and the very first laboratory where humanity learned what a planet truly is. There are 8 recognized planets orbiting the Sun, each with its own unique character, history, and mysteries. Let us travel through them one by one, starting closest to the Sun and moving outward. Mercury is the smallest planet in our solar system and the one closest to the Sun. It has no atmosphere to protect it, so its surface is blasted by extreme heat during the day and bitter cold at night. Temperatures can swing from over 400 degrees Celsius in sunlight to minus 180 degrees Celsius in darkness. Its surface is covered with craters, much like our moon, showing that it has been scarred by countless collisions over billions of years. Despite its small size, Mercury moves swiftly around the Sun, completing one orbit in just 88 Earth days. It is a planet of extremes, a tiny world baked and frozen by the star it cannot escape. Venus, the second planet, is often called Earth's twin because of its similar size and rocky nature. Yet it is anything but hospitable. Shrouded in thick clouds of carbon dioxide and sulfuric acid, Venus experiences a runaway greenhouse effect, making it the hottest planet in our solar system. Surface temperatures reach over 460 degrees Celsius, hotter than Mercury, despite being farther from the Sun. Its surface pressure is over 90 times that of Earth. Standing on Venus would feel like being crushed under the ocean. Once, scientists wondered if Venus might host oceans and life, but today we know it is a hostile inferno, both fascinating and frightening. Earth, our home, is the third planet and the only one we know that harbors life. Its balance of atmosphere, water, and distance from the Sun creates the conditions for biodiversity, from the smallest microbes to vast forests and intelligent beings who question their place in the universe. Earth's magnetic field shields it from harmful solar radiation, and its dynamic surface, shaped by plate tectonics, makes it ever-changing. What sets Earth apart is not just its physics, but its biology, the spark of life that makes it unique among the planets we have explored so far. When asking how many planets exist, we must also ask, how many Earths are out there? How many living worlds circle other suns? Mars has captured human imagination for centuries. Known as the Red Planet because of its iron-rich soil, Mars is dry and cold, with a thin atmosphere made mostly of carbon dioxide. Yet, it bears signs of a wetter past, ancient riverbeds, dried-up lakes, and even polar ice caps. Robotic explorers like Curiosity and Perseverance roam its surface, searching for evidence of past or present life. Humans dream of setting foot on Mars, seeing it not only as a neighbor, but as the next frontier. If Earth is the cradle of life, could Mars one day be its second home? Jupiter, the fifth planet, is the largest in our solar system, a gas giant so massive that all other planets could fit inside it. Its swirling atmosphere is marked by the Great Red Spot, a storm larger than Earth that has raged for centuries. Jupiter has no solid surface, only layers of gas and liquid surrounding a possible dense core. It also has a powerful magnetic field and more than 90 moons, including Europa, Ganymede, and Callisto, moons that may hold oceans beneath their icy crusts. In many ways, Jupiter is a planetary system of its own, a giant that protects Earth by diverting comets and asteroids with its gravity. Saturn, famous for its stunning rings, is another gas giant, second only to Jupiter in size. Its rings are made of countless particles of ice and rock, orbiting like a celestial ballet. Saturn's atmosphere is calm compared to Jupiter's, but its beauty lies in its elegance. It has more than 140 moons, with Titan being the most intriguing. Titan has a thick atmosphere and lakes of liquid methane, making it a world that scientists are eager to study for possible signs of chemistry that might resemble life. Saturn is a reminder that planets can be not just places, but breathtaking works of art in the cosmic gallery. Uranus is unlike any other planet. It rolls around the Sun on its side, tilted over 90 degrees, perhaps due to a massive collision in its past. This tilt makes its seasons extreme. each lasting over 20 years. Uranus is classified as an ice giant, made mostly of water, methane, and ammonia, giving it a pale blue-green color. Its atmosphere is freezing, and yet, it still possesses faint rings and at least 27 moons. Though less explored than other planets, Uranus holds secrets that future missions may unlock, especially about the outer reaches of our solar system. At the edge of our planetary system lies Neptune, the eighth planet. Deep blue and mysterious, Neptune is whipped by the fastest winds in the solar system, reaching over 1,600 kilometers per hour. Like Uranus, it is an ice giant, but its vivid color and dynamic weather make it extraordinary. Discovered in 1846 through mathematical prediction, Neptune proved that the laws of gravity could lead us to hidden worlds. Its largest moon, Triton, is believed to be a captured object from the Kuiper Belt, hinting at the complexity of the outer solar system. Together, these 8 planets form the family of worlds that orbit our Sun. But while they are unique, they are not the only worlds. Beyond Neptune lies a population of dwarf planets, like Pluto, Eris, and Haumea, and beyond them stretches the Kuiper Belt and Oort cloud, reservoirs of icy bodies. The story of planets in our solar system is only the beginning of a far greater tale, one that extends to the stars. While the 8 major planets often dominate the spotlight, they are not the only worlds orbiting our Sun. Beyond them lies a fascinating collection of dwarf planets, moons, and small bodies that remind us of the richness of our solar system. To understand how many planets, or planet-like worlds, truly exist, we must also look at these hidden members of the cosmic family. The most famous dwarf planet is Pluto, once considered the 9th planet of our solar system. For decades, Pluto captured human imagination with its icy surface and mysterious orbit. However, in 2006, the International Astronomical Union reclassified Pluto as a dwarf planet because it failed one of the 3 requirements of being a true planet, clearing its orbital neighborhood of other debris. Yet, Pluto remains one of the most studied and beloved objects in astronomy. NASA's New Horizons mission in 2015 revealed breathtaking images of its surface, towering mountains of ice, vast plains of frozen nitrogen, and hints of geological activity. But Pluto is not alone. Other dwarf planets include Eris, a world even more massive than Pluto, discovered in 2005 and located in the scattered disk region beyond Neptune. Haumea, with its elongated, football-like shape and fast rotation, stands out as one of the strangest objects in the Kuiper Belt. Makemake, another distant icy world, reflects sunlight brilliantly, making it one of the brightest objects in the outer solar system. And closer to home lies Ceres, the only dwarf planet in the asteroid belt between Mars and Jupiter. Ceres is particularly intriguing because it may hold large amounts of water beneath its surface, raising questions about whether microbial life could ever have existed there. Altogether, these dwarf planets remind us that the solar system is not just about 8 large worlds. It is a continuum of countless bodies, some large enough to be nearly planetary, others small but still full of scientific importance. If we widen our definition of worlds to include moons, then the number of planets or planet-like bodies multiplies enormously. Jupiter alone has more than 90 moons, Saturn has more than 140, and the other planets also host dozens. Many of these moons are as fascinating, if not more so, than some planets themselves. Take Europa, one of Jupiter's moons. Beneath its icy surface lies a global ocean, kept liquid by heat from tidal forces. Scientists believe this ocean could harbor conditions suitable for life, making Europa one of the top candidates in the search for extraterrestrial organisms. Similarly, Enceladus, a small moon of Saturn, ejects plumes of water vapor and ice from cracks in its surface, hinting at a hidden ocean beneath. These jets even contain organic molecules, fueling the hope that life could exist there. Then there is Titan, Saturn's largest moon, larger than the planet Mercury. Titan has a thick atmosphere and lakes of liquid methane and ethane on its surface, creating a landscape eerily similar to Earth's, but based on entirely different chemistry. Scientists are eager to explore Titan, as it may hold the key to understanding alternative pathways for life. Other remarkable moons include Ganymede, the largest moon in the solar system and the only one with its own magnetic field, and Triton, Neptune's largest moon, which orbits in the opposite direction of its planet's rotation, suggesting it was once a captured object from the Kuiper belt. These moons expand our definition of planets because they are dynamic, complex, and in some cases, potentially habitable. Beyond Neptune lies the Kuiper belt, a vast ring of icy bodies stretching billions of kilometers from the Sun. It is here that Pluto, Haumea, and Makemake reside, along with countless smaller objects. The Kuiper belt is thought to be the source of many comets and is a relic of the early solar system, a frozen archive of how planets were formed. Even farther lies the Oort cloud, a hypothetical shell of icy objects surrounding the solar system at nearly a light-year away. If the Kuiper belt is like a cold frontier, the Oort cloud is the ultimate edge of our solar neighborhood. Though it has never been directly observed, scientists believe it exists because of the long-period comets that occasionally streak into the inner solar system. If the Oort cloud is real, it could contain trillions of icy bodies, perhaps the largest population of planet-like objects connected to our Sun. Astronomers suspect there may even be another large planet lurking far beyond Neptune, sometimes called Planet 9 or Planet X. Its existence has not been confirmed, but unusual patterns in the orbits of distant objects suggest that a massive planet, perhaps 10 times the size of Earth, could be hiding in the outer reaches of the solar system. If found, it would transform our understanding of the solar system structure and raise the official count of planets once more. Thus, when we consider dwarf planets, moons, the Kuiper belt, and possibly Planet 9, the number of significant worlds in our solar system grows far beyond 8. Each of these worlds adds a new dimension to the story of planets, showing that the line between planet, dwarf planet, and moon is sometimes blurred. They remind us that the universe does not fit neatly into human categories. It is far richer and more complex. If the 8 planets of our solar system are the first chapter of the planetary story, then exoplanets are the vast library waiting beyond. Exoplanets are planets that orbit stars outside our solar system, and their discovery has completely changed the way we think about the universe. For thousands of years, people wondered, are there other worlds like our circling distant suns? Today, we know the answer is yes. Not only do such planets exist, they are astonishingly common. The first confirmed exoplanets were discovered in 1992, not around a star like our Sun, but around a pulsar, a rapidly spinning neutron star left behind after a supernova explosion. This discovery shocked scientists because it showed that planets could exist in places once thought impossible. Just a few years later, in 1995, astronomers discovered 51 Pegasi b, the first exoplanet found around a Sun-like star. This planet was a hot Jupiter, a giant gas planet orbiting extremely close to its star, completing an orbit in just 4 days. It defied expectations and forced astronomers to rethink planetary formation theories. As technology improved, the search for exoplanets exploded. Ground-based telescopes detected dozens, then hundreds. But the true revolution came with space missions like NASA's Kepler Space Telescope, launched in 2009. Kepler stared at a single patch of sky for years, measuring tiny dips in starlight caused by planets passing in front of their stars. In less than a decade, Kepler discovered over 2,600 confirmed exoplanets and identified thousands more candidates. Suddenly, the universe looked like a place overflowing with worlds. Kepler was followed by missions like TESS, Transiting Exoplanet Survey Satellite, launched in 2018, which scans nearly the entire sky, and the James Webb Space Telescope, JWST, launched in 2021, which can not only detect exoplanets, but also analyze their atmospheres. These missions are revealing an incredible diversity of planets, from scorching hot worlds that hug their stars to icy giants drifting in darkness, from rocky Earth-sized planets to super-Earths and mini-Neptunes that have no counterpart in our solar system. As of now, astronomers have confirmed more than 5,000 exoplanets in over 3,000 planetary systems. New ones are being added regularly. But these are just the tip of the iceberg. Based on data from Kepler, scientists estimate that there are at least one planet per star in our galaxy alone. Since the Milky Way contains over 100 billion stars, that means there could be 100 billion or more planets in our galaxy. If we extend this to the entire observable universe, with its 2 trillion galaxies, the number of planets becomes almost unimaginable, trillions upon trillions of worlds scattered across space. Exoplanets come in incredible varieties. Some orbit so close to their stars that their atmospheres are boiling away, while others orbit so far out that they are frozen solid. Astronomers classify them into categories. Super-Earths, rocky planets larger than Earth, but smaller than Neptune, potentially habitable in some cases. This diversity tells us that planetary systems are far more creative than we imagined. Our solar system, with its neat arrangement of small rocky planets near the Sun and large gas giants farther out, might actually be unusual compared to the wild variety of systems out there. One of the biggest goals in exoplanet research is to find Earth-like planets in the habitable zone, the region around a star where liquid water could exist. Kepler data suggests that there may be billions of Earth-sized planets in habitable zones within the Milky Way alone. Some of the most promising include Proxima Centauri b, orbiting the closest star to our solar system, just 4.24 light-years away. Others, like the planets of the TRAPPIST-1 system, orbit a small red dwarf star 40 light-years away. TRAPPIST-1 has 7 Earth-sized planets, 3 of which are in the habitable zone. It is one of the most exciting systems for future study, as it could potentially host life. The discovery of exoplanets has reignited one of humanity's oldest questions: are we alone in the universe? If planets are so common and if billions may be Earth-like, then it seems statistically likely that life could exist elsewhere. Scientists are now working to study exoplanet atmospheres with telescopes like JWST, searching for biosignatures, gases like oxygen or methane that could indicate biological activity. Finding such signs would be one of the greatest discoveries in history, proving that life is not unique to Earth. When we consider all the exoplanets discovered and all the stars yet to be studied, the number of planets in existence becomes mind-boggling. Imagine walking on a beach and picking up a single grain of sand. That grain is Earth, and the entire beach represents the planets of the universe. For every star you see in the sky, there may be one or more planets orbiting it. Multiply that by billions of stars per galaxy and billions of galaxies in the universe, and the total number of planets may exceed human comprehension. Thus, when we ask how many planets exist in the air, or rather in the universe, the answer is not just 8, not just thousands, but potentially trillions. The cosmos is a planetary ocean, and we are only beginning to sail its shores. As we gaze into the endless ocean of the universe, one question rises above all others: how many of these planets could be habitable? To us, a habitable planet is one that can support life, most often imagined as life similar to Earth's. That means it would need the right temperature for liquid water, a stable atmosphere, essential chemical elements, and perhaps a protective magnetic field. But when we consider the billions of planets that exist, the chance that some of them meet these conditions becomes not just possible, but likely. Astronomers use the term habitable zone, sometimes called the Goldilocks zone, to describe the orbital distance from a star where a planet's surface temperature could allow liquid water. Earth, of course, sits comfortably in this zone around the Sun. Venus is too close, boiling and suffocating, while Mars is slightly too far, cold and thinly atmosphered. Yet, Mars still shows potential signs of past habitability. In the same way, many exoplanets orbit their stars in habitable zones, and the search for Earth 2.0 often begins there. But habitability is more complex than distance alone. A planet's atmosphere can create a greenhouse effect that makes it warmer, as Venus shows, or help trap heat to maintain stability, as Earth does. A planet too small may lose its atmosphere, while a planet too large may hold onto thick gases like Neptune. Thus, finding habitable planets requires not just measuring distance but analyzing composition, mass, and atmospheric chemistry. If habitable planets exist, the next question is whether life has arisen on them. Life on Earth began surprisingly early, within a few 100 million years after the planet cooled. This suggests that life may emerge easily when conditions are right. Microbial life could potentially exist on billions of planets across the universe. Advanced, intelligent life, however, may be much rarer, shaped by chance, evolution, and stability over billions of years. The discovery of even microbial life beyond Earth would be revolutionary. It would mean that life is not a miracle unique to our world, but a natural outcome of chemistry and physics. Some scientists even propose that life may not only exist on planets, but also on moons like Europa, Enceladus, or Titan within our solar system. If life is found there, it will mean the universe teems with biology in ways we cannot yet imagine. Modern telescopes like the James Webb Space Telescope, JWST, are equipped to study the atmospheres of distant exoplanets. By analyzing starlight passing through a planet's atmosphere, scientists can detect gases like oxygen, methane, or carbon dioxide, which may indicate biological activity. In the coming decades, new missions such as the European Extremely Large Telescope, YELT, and NASA's Future Habitable Worlds Observatory aim to directly image Earth-like planets, potentially capturing their blue oceans, white clouds, and green surfaces. Closer to home, the search for life continues on Mars, Europa, and Titan. NASA's Perseverance rover is currently collecting samples on Mars that will one day be returned to Earth, possibly answering the question of whether Mars once hosted life. The upcoming Europa Clipper mission, set to launch in the 2030s, will explore Jupiter's moon Europa, investigating its icy shell and subsurface ocean. Meanwhile, the Dragonfly mission will send a drone-like lander to Titan, Saturn's largest moon, to study its exotic chemistry and potential for life. While robots have been our first ambassadors, humans are preparing to take the next step. NASA's Artemis program aims to return humans to the moon by the mid-2020s, establishing a permanent base as a stepping stone to Mars. Elon Musk's SpaceX is also working on plans to send humans to Mars within the coming decades. If successful, humanity will become a multi-planetary species, opening the door to colonizing other worlds. The planets of our solar system will no longer be distant objects of study, but potential homes. When we look at the sheer number of planets, billions in our galaxy, trillions in the universe, it reshapes our sense of place. Earth is no longer the center of everything, nor is it even a rare jewel. Instead, it is one among countless worlds. And yet, for now, it is the only one we know that supports life. This dual truth, that planets are everywhere, yet life is still rare to us, creates a sense of both humility and wonder. The journey of discovery is still in its early stages. Every exoplanet found, every mission launched, and every new telescope opened to the sky adds another piece to the puzzle. The question of how many planets exist is no longer simply about numbers. It is about the stories those planets hold, the possibilities they represent, and the destiny they may one day shape for humanity. From the blazing surface of Mercury to the icy winds of Neptune, from the mysterious dwarf planet Pluto to the frozen oceans of Europa, from the super-Earths discovered by Kepler to the countless rogue planets drifting between the stars, the universe reveals itself as a boundless ocean of worlds. The original question, how many planets exist in the air, or rather, in space, has led us on a journey across scales so vast that human imagination struggles to contain them. We began with the 8 familiar planets of our solar system, each a world with its own story. Then we looked outward, to dwarf planets, moons, and the hidden treasures of the Kuiper Belt and Oort cloud. And beyond them, we entered the realm of exoplanets, where discoveries number in the thousands, with billions more waiting to be found. The truth is that planets are not rare exceptions, they are the rule. Nearly every star we see may host its own family of worlds, and in the grand architecture of the cosmos, planets may number in the trillions. But the real magic of this realization lies not only in the numbers, but in the possibilities. Among those countless worlds, how many resemble Earth? How many hold oceans, mountains, or skies filled with clouds? How many could be cradles of life?
We do not yet know.
Perhaps some are alive right now, teeming with creatures we cannot imagine, while others may be waiting for the spark of life to ignite. For humanity, This knowledge carries both wonder and responsibility. We are a species born on one small blue planet, yet we now stand at the threshold of becoming explorers of many. Our telescopes are peering across light years, our spacecraft are crossing the void, and our dreams are reaching out to Mars and beyond. The planets remind us that we are not confined to one world, but are citizens of the cosmos. So, when we ask how many planets exist, the answer is more profound than any number. It is that the universe is overflowing with them, and with every discovery, we expand the horizon of what is possible. Planets are not just distant objects of rock, ice, or gas. They are stories waiting to be told, homes waiting to be explored, and perhaps, one day, places where humanity will continue its journey among the stars. And maybe, somewhere out there, on one of those countless planets, another being is asking the very same question: how many worlds exist in the air?